Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this video, we're going to be covering ions. Let's get started. In previous videos, I've discussed what atoms are, and we talked a lot about what happens to the subatomic particles when we're dealing with neutral elements, meaning that the protons and the electrons are equal. But what happens when they don't equal one another? Well, when they don't equal one another in a particular atom, that's when we can generate what are called ions. Ions are generated by either losing or gaining electrons. Now, the number of electrons in a neutral atom will be equal to the number of protons, and we've said that a few times throughout different videos. Now, during chemical changes, however, atoms can often lose or gain electrons to form these charged particles called ions. And so we can have examples where we're either losing electrons, and that's when we're going to be generating what are called cations, or you could be gaining electrons, and that's when we're generating anions. Now, whether you're going to be forming an anion or cation is really dependent on the number of electrons that you have. However, typically speaking, in a compound, cations and anions will come together to form a molecule to form a compound that overall has a neutral charge. So we have to be familiar with what types of electrons actually exist within an atom. There are two different types of electrons that exist. There are your valence electrons, which are considered to be your outermost shell electrons. So those are the ones that are easily removed, or you can add things in, and often are involved in chemical reactions in the bonding process. Typically, most main group elements prefer to have 8 electrons in that outermost shell. We also have the core electrons, which are found central in the nearer or closer to the central area of the nucleus, and those ones are not so much involved in the bonding process. So as ions are forming, we're really trying to obtain that closed shell configuration. What closed shell means is either my shell, that valence shell, is completely full with 8 electrons, meaning I've gained enough to add 8 in there, or completely empty, meaning I've kicked everybody out to get down to 0. Now, whether or not an element is going to be gaining or losing electrons, again, is dependent on how many electrons are present there. So our main group metals tend to lose electrons. And so if you look at your periodic table is very loosely drawn like this. The far left side, these are your metals. And so metals tend to lose electrons. They kick out the electrons to have 0 in its valence shell. This top corner up here, these represent your nonmetals, and they're going to be gaining in electrons in order to fill that valence shell. So things like sodium or magnesium, they're going to lose electrons to form or obtain the same number of electrons as the noble gas that comes before it. So both sodium and magnesium kick out those electrons in order to become either positively 1 charged or negatively 2 charged, respectively. Now, our main group nonmetals, they tend to gain electrons, and so they're going to be adding in electrons to get up to 8. So something like chlorine, which has 7 electrons, it's going to add in another electron, and as I add that one more negative species, I become more negative to take on a -1 charge. Oxygen, -2, nitrogen, -3. Now, it's very easy to predict what charge something is going to have based off of the group that it's found in. So again, if we look at our periodic table, which is found here, when I'm referring to groups represent the columns that are found in these two regions. The main groups are those columns. And so the column number coincides with the number of valence electrons something has. Group 1 or column 1 would have 1 valence electron. So it's easy to kick that 1 electron out and get down to 0 in that valence shell. Group 2 would have 2 valence electrons. Group 3, 3 valence electrons. All right, now let's look on the flip side. Group 7, something like where chlorine is found, has 7 valence electrons. So rather than kicking everyone out, it's easier to go get 1 more electron and get up to the 8. Group 6 would add 2 more to become 8 valence electrons with a -2 charge. Group 5 would gain 3 more to get to that 8 valence electrons or a -3 charge. Now, group 4 can actually go either way. It can either lose its electrons, those 4 electrons, to take on a +4 charge, or gain electrons to get up to 8 to have a -4 charge. Again, that will be really dependent on what other elements it's binding to. So make sure that you're familiar with where groups are found on the periodic table and how to predict how many valence electrons something has, and subsequently what charge it would take on. So here we want to actually predict the charge of the following and state whether it'll be a cation, anion, or neutral based on the number of electrons it would like to lose. So if you find aluminum on your periodic tables, aluminum is in group 3. So it would want to kick those 3 electrons out. So as a result, it would be forming aluminum with a positive 3 charge. Okay, so that's the additional charge we would show if we were writing the atomic symbol. Sulfur, you can see, is in group 6, and so it's a lot easier to add 2 more to it than kick 6 out. And so as you add 2 negative electrons, the charge is going to become sulfur with a negative 2 charge. Bromine is found in group 7. With 7 electrons already in the valence shell, it's a lot easier to add 1 more to it. So our bromine would end up taking on a negative 1 charge. Potassium, which is found in group 1, it's a lot easier to kick that 1 electron out. And so if I lose 1 negative electron, I would then take on a positive 1 charge. And then last but not least, calcium, which is found in group 2. I can kick those 2 electrons out. And as a result, I have that imbalance in the electrons and the protons, and therefore end up with a positive 2 charge. Remember, when we're forming ions, we never change the number of protons. Protons are how we identify an atom or an element. And so the protons remain fixed, and we just adjust the electrons accordingly. So the next question says we want to write the atomic symbol for neutral barium and the barium cation. So remember, the atomic symbol has those 3 components, and we may add an additional piece if we're dealing with an ion. So neutral barium, the symbol is Ba for barium. The atomic number for barium is 56, and that represents the number of protons that we have. The mass number would be 137. And remember, that equals the number of protons plus neutrons. Now, if we're dealing with the cation, we have to take a look at what group is barium found in. Barium is a group 2 metal, and so we would expect that it's going to kick out electrons to get to that 0 closed shell configuration. So if I have 2 electrons I got to kick out, that means that when I lose those 2, the overall charge would become a positive 2. I have 2 more protons that remain compared to the electrons that remain. So the symbol would still stay as barium. The atomic number would still stay as 56. The mass number would still stay 137. But what changes is that we add this 2 plus charge here to represent that it has lost that respective number of valence electrons. If we look at chlorine and we want to write the atomic symbol for neutral chlorine and the chlorine anion, we again have to look at where chlorine is located on the periodic table to help us get that anion symbol correct. So if we start with the neutral species, we again know that the symbol is Cl. Its atomic number would be 17. And then the mass number would be 35, where we're writing that whole number, which represents the protons plus the neutrons. For the ion, the anion, notice again it's saying anion, that negative anion. What we're going to say is that chlorine, the number of protons remains the same, so the number of protons remains the same, so therefore the atomic number remains the same. We haven't changed the number of neutrons, so the mass number also stays the same. So the mass number also stays the same. But now, because we're dealing with an anion, we know that chlorine is in valence, would have 7 valence electrons because it's group 7. So we're going to add in 1 more electron. And so as we add in that additional electron, it takes on a negative charge. A good way to remember cations versus anions. Cats, if you take a look at the first part of that word cat, a lot of people think cats are positive, they make them happy. So cation are going to be positively charged species. And in anions, if you look at that real quick, it's spelled kind of like onions. And if you eat onions, you could have bad breath. Bad is negative. So anions are going to be negatively charged. But in order to figure out the exact charge that you would write, you have to look at the group number. What column is that element found in? If it is in columns 4 or below, you likely are going to be losing your electrons and generating a positively charged cation. If it's 4 or above, then you could be generating an anion because you're gaining in electrons. I hope this video helped you guys understand ions and the differences that exist amongst them. Stay tuned for more videos. Be sure to subscribe, like, and comment below for additional content you would like to see. Have a great day, and I'll see you guys soon. Bye.